When we meet on Thursday, we'll be back in the computer lab, though. We'll have a quiz at the beginning of class, and then we'll continue talking about Breakeven, which is the discussion we're having today. Just a reminder about the class project. What I've done is I've created a spot on iLearn for you to upload your report to. And I'd like you to put everything into a single file, whether it's a PDF document or a Word document. But as it explains in the original description for the project, you're supposed to be estimating what your income will be and your expenses after you graduate for the whole rest of your life. And so this draft submission is a chance for me to see what you've done so far and give you some feedback on that. The deadline will be 5 o'clock on Monday of next week. Any questions about the announcements? Okay. We're starting on chapter 13 in the book, Breakeven. And the way that I'm going to present the material today is a little bit different from what's in the text. There are actually two different ways to approach the topic, and I'm going to show you both. So the things we do today, I know there are some of you who are doing a good job following along in the book and reviewing the material from the text. So don't be thrown off if what we're doing today doesn't yet match what's found in section 1 of chapter 13. We'll get there. All right, let's start with the picture. Here's a photo, and I want to see if you know what this is. I don't suppose anyone's been to that store, Best Buy, because they don't have them here in the UAE. What do you think's happening in this picture? Yeah, people are awake in the middle of the night. It's still dark out, and this is Black Friday, right? Yeah, this week there are two holidays in the United States. One of them is an official holiday, and one is sort of an unofficial holiday. The official holiday is Thanksgiving, which is on Thursday, and that's the one where people are eating turkey and pies and mashed potatoes. I'm really going to miss it. It's one of my favorite holidays. Maybe I'll have a chicken shawarma instead of turkey. I don't know. It's my UAE Thanksgiving. The day after Thanksgiving, though, is it's called Black Friday. It's not an official holiday, but it's just when everyone starts to begin their holiday shopping in the U.S. And so here you can see people are lined up, and sometimes people will start getting in line. They eat their Thanksgiving meal, and then they go get in line for the sales the next day. Someone's sitting here in a folding chair because they've been waiting for so long. The reason why everyone is standing in line is because the prices are so low. The newspaper on Thursday has all the advertisements saying what the sale will be at Walmart, what the sale will be at every store, and so you spend after your meal on Thanksgiving, you get the newspaper and you start figuring out what will be the order of the stores that you go to and all the things you're going to have to push and shove to get. Sometimes this can erupt almost into a riot because people are so anxious to save $5 on a TV, something like that. So what we're talking about today is demand, and this is a good illustration of demand and why it happens. Price demand is what we're going to be talking about, and as a retailer or as someone who sells an item, you can't control directly how many people are buying your item. But what you can do is you can indirectly control the amount of demand by adjusting your price. So price is an independent variable. Independent means that it's controlled. The dependent variable is the one that responds to the price, and so for us the demand is a dependent variable, and so the relationship, if you're selling an item and you increase the price of it, then the demand should decrease. But if you decrease the price of it, then the demand will increase. So think of it this way. If you began to offer a Bentley, here is demand, and here is price. What if the Bentley you're trying to sell is 2 million dirhams? Very few people are going to want to buy the car at 2 million dirhams. But for the same car, the same vehicle, now you're charging 1 million dirhams. Maybe there will be some more people, not a lot more. But then all of a sudden, what if you're offering the Bentley for 100,000 dirhams? Everyone's really excited. The demand is high. So we can draw a line through that demand curve and express the relationship between what is our asking price. If the asking price is low, the demand is large. If the asking price is high, the demand is low. Today, what we're going to do is assume that this curve is linear. That may or may not be the case in reality. It could be that the curve is like this. It could be that you have to lower the price, and as soon as you lower price just a little, there's a huge increase in demand. Or it could be the other way around. It could be like this, where you have to lower the price so much and then suddenly the demand increases very suddenly. But for today's purposes, we're going to, just for simplicity of introducing the subject, we're going to be talking about the price-demand relationship as being linear. Any questions so far? Now here you can see that what we've done is we've assigned variables to this linear relationship here. P is price, A is the intercept with the vertical axis. So by intercept, what that means is, what is the price when there's no demand? If we keep increasing our price so much, what is the price that no one would buy the item for? The first price. Because of course, back to the idea of Bentley, maybe we would have one person who would buy it for 2 million dirhams, but what is the price when suddenly there's no more buyers? That's the meaning by that intercept A. Now B, on the other hand, that's talking about the slope of the line. So how much does the demand increase for each unit decrease in price? So if you decrease the price of the Bentley by 1 dirham, how many more units are you going to sell? Probably you'd have to decrease it a lot more than 1 dirham to start increasing the demand. But the slope of that line is what we're assigning to the variable B. And then D is just the number of units that are sold. And today we're going to have a couple of variables that are with the letter D. We're going to have D, D prime, D hat, and D star. Confusing, right? It always means demand, but it means demand at a certain point. So D is just the generic variable demand. How many items are being sold? Good question. Yeah, how do you know what this curve looks like? Well, you may have an economist on staff who looks at competing products and predicts it based on the amount of units that are sold in the market and how they think your item that you're going to sell compares to the other ones that are already on the market. It could be actual price data. So, where does this curve from? It could be a lot of different sources, but luckily for us, they give us the curve. So we do our calculations after we already have the price curve defined. The rest of these, I'll introduce those one by one. All right, so if you know the price of the item, what you're charging people for it, the price per unit, and you know how many units are sold, then you can calculate revenue. Revenue is the money that you're coming in for selling the item. So it's how many are sold times the price for each item. If we substitute in the formula for P, which is A minus BD, then the revenue, total revenue, you can see here is this function. You can calculate the two separately. You don't necessarily have to combine them. But the revenue is going to be one of the factors that helps us to understand what is the profit. And really what it's all about when you're operating a company is maximizing the profits. And so to maximize the profits, we have to understand what the revenue curve looks like. Here's what the revenue curve looks like. This is interesting that it has a shape like this. And let's try and think about why is it that you would have a low revenue over on the left side of the curve. You have a low revenue here because the price is high on this side of the curve. If you have low demand, remember what caused low demand was high prices. So if you have low demand, you're getting a lot for every unit, but you're selling so few units that you're not making much revenue. And so that's why this blue line, our revenue curve, is low on the left side. Who can explain why the curve is low on the right side? That's right. So we have a lot of demand, but we're selling it too cheap. And so our revenue is low again. Mm-hmm. This would be for a single item, yeah. So every item is going to have its own unique demand. So if you have a company that's selling kitchen utensils, there's going to be a different demand for frying pans than there will be for soup ladles. So you'd have to do the analysis for each item that's being sold.
Yeah, but looking at this graph, then some companies can actually avoid this other part of the graph, right? They don't have to go through having high demand and low prices.
That's what you don't want to do, is you don't want to be selling for anything other than the maximum profit. On a subsequent slide, in just a moment, I'm going to show you how to calculate the optimal demand. So D hat, which is shown here, this is for maximum revenue. So maximum total revenue, and here's the formula for it. It's A squared divided by 4B for the maximum total revenue, or just to find the demand at the maximum total revenue, A divided by 2B, where what we're talking about with A and B are the variables that are into our price curve. Remember though, we're not trying to maximize revenue when we're in a company. What we're trying to do is we're maximizing our profits. And so for us to know what our profits are, we also have to consider the costs, because profit is revenue minus cost. And so the costs have two components, the variable costs and the fixed cost. Fixed costs are things that are unaffected by the level of activity of a company. So think about if you own a factory, you have to pay rent for the land and for the building, regardless of whether your factory is making 100 items or 1,000 items. Your fixed costs are the things that are a recurring expense that are unaffected by how many items you're actually making. Variable costs, on the other hand, are related to how many items you made. And so if you're making frying pans, your variable costs would be the steel that goes into the frying pans. It could be related to the wages of the workers that are in the factory. You may have some variable costs related to electricity, where you're having to pay more electricity for the more hours that the assembly line is in operation. So the total cost is the sum of the fixed and the variable. The variable itself has two components though, because there's the overall variable cost, but this lowercase c sub v here, there's two c sub v. The capital C sub v means the overall variable cost, but the lowercase c sub v means the variable cost per unit. And so what is the cost for making each individual frying pan? You know, how much steel is in a frying pan? Probably, well, like 10 fils worth of steel. And how much electricity goes into making one frying pan? So that's what is meant by the variable cost per unit. And so if you know how many units are being made and the variable cost per unit, that's where the overall variable costs come from. Any questions so far? So the reason why we're trying to find the variable costs is, remember, we want to maximize our profits. So we want a lot of revenue, of course. What we really want is we want a lot of revenue and low cost. We want those two to be as far apart as possible. The furthest apart revenue and costs are, that's what gives us a lot of profits. So it's the difference between revenue and cost. Now, optimal demand helps us to find the point at which we have the most profit. And it's actually a graphical solution. I'll show you a curve in a minute that includes both our cost function and our revenue function. And optimal demand is the point on the curve that these two things are the furthest apart. the revenue and the costs are the furthest apart. This C sub V that's shown here, that's the variable cost per unit. And then A and B are the prefixes that come from our cost curve. All right, the last thing I want to show you is the formula for the break-even points. Now, we're using the word break-even here a little bit different from how we talked about break-even earlier in the semester. One of the earlier times we showed break-even was with a cash flow diagram, and we said, here's some first cost to buy the equipment, and how much revenue do we have to collect each year in order to break even, right? That was break even in the sense of the time value of money, where we had some interest rate and we were finding out A equals what to break even from our first cost. Okay, so that's one way to use the word. What we're talking about today, though, isn't that time value version of break even. It's just break even is when the revenue and the costs are equal, then that means there's no profit. So break even for our purposes is how many units do we have to sell in order to cover the costs with our revenue? Okay, we're going to look at this curve for a minute. This is a really important one. Sometimes on quizzes, I'll show you a picture and I'll say, explain this. And then you have to tell me the story of what's happening with a certain figure. So let's look through what this is showing. What's this curve? The one that goes up and then down again, revenue. Okay? And why is revenue low on the left side? Because the prices are so high that people aren't buying very many. And the revenue is low on this side because our prices are so low, people are buying a lot, but we're not getting much money because our prices are so low. All right, so that's our revenue curve. We've seen it before. Okay, C sub F stands for what? Fixed cost. And you'll notice that no matter if we have a low volume or a high volume, our fixed cost is the same. So that usually is having to do with rent or whatever the expenses are that aren't related to how productive our enterprise is. Total costs are affected by the demand. In other words, the total costs are affected by how many units we're making and selling because they include the variable costs. C sub V is the overall variable cost that includes the materials that go into the item itself, the labor costs associated with a certain level of productivity. And so C sub T is C sub V plus C sub F. All right. What we want to do as a company is we want to have maximum profits. So if you look this shaded area here, it's shaded in gray. We want to have the point at which the revenue curve is really high above the cost curve. And you can see that they've indicated the maximum profit here. That's where this line is the biggest, is where we have the most profit. Think about like right here on the left side of the screen. The revenue isn't very much higher than the costs at this point. So if I sell this many, that's better for our company because now the revenue is higher than the cost. I want to find the point at which these two lines are the furthest apart because that is the most profit. And what do you notice about the curves and the slope of the curves at this point that they've labeled maximum profit? The slopes are parallel. They're equal, right? So at first, they're getting further apart, and then they're parallel just momentarily, and then they're getting closer together. And so graphically speaking, this location where the two curves are parallel is the point of maximum profit. And that's here the D star is the optimum demand. That's how many units we should sell. And so what should we charge for our item? What should our price be? It's whatever the price is that will get us this much demand. If we lower our price more than that, we're going to get too much demand. And then our revenues are lower because we're not collecting as much money per item. If we have less than that optimal demand, we haven't got enough people buying it because our prices are too high. So we've talked about D, it just means demand. We've talked about D hat, that's maximum revenue. D star is optimal demand, meaning maximum profit. Just by looking at the graph, what is D prime? Yeah? Breaks even. What does it mean, break even? Revenue and costs are equal. And remember, cost includes two components. It's the fixed cost and the variable cost. And so D prime 1 means the first time that you have a break-even point. But there's a second break-even point where if you sell more than D prime 2, you're losing money again. And you're losing money at that point, to the right of D prime 2, you're losing money again because your prices are too low. All right? Yes? If the fixed costs were higher, then we'd have a smaller range of profits. So if our costs go up, that would shift D prime 1 to the right. And it would shift D prime 2 to the left. It would. It would decrease the area of our profits. If the costs go up, it's going to eat into our profits. Absolutely. All right. So here's our in-class exercise for today. We have a company that is producing an electronic timing switch. It doesn't matter to us what they're making, but that's what they're making. We know that the fixed costs, C sub F, are $73,000 per month, and then the variable cost per unit is $83. So whatever the materials are that's going into that unit, it's $83 for each of them. Our marketing department or our economist or our market research, someone has suggested that this will be the relationship between price and demand. So $180 is the price that we should set if we want zero demand. And then if we have a lower price than that, we'll start to have positive demand. So with this, remember there's the variable A and B that we can get from knowing the price curve. I'd like you to go through and calculate optimal demand for this product, the demand that's going to give us the maximum profits, so that's D star. Then find out what is the maximum profit at that optimal demand. And then part C is the break-even points, and so that's D prime 1 and D prime 2. And finally, once you've found all of those amounts, draw a curve similar to this one, but label our particular points on that curve. All right, the optimum demand is 2425 units. That's the number of units that's going to maximize our profit. That's not the number of units for maximum revenue, because we're not trying to maximize revenue, we're trying to maximize profits. Okay, on the board I've written one approach to do it, and then on the screen I have another. Maybe the easier thing to do is find out for 2425 units what should be your selling price. And so you would substitute into the price equation. Our price equation was P equals 180 minus 0.02 times the demand. For us, 2425. Did anyone calculate what is the selling price at that volume? 131.5? All right. So you can find your revenue at optimal demand by multiplying the number of units sold by the price that you're charging for each unit. So the price for each unit, $131.50 multiplied by 2425 items. And that will tell you the revenue part of it. And the cost of it is the fixed cost which is 73,000, plus the variable cost per unit, which is $83 for every unit that we sell, and then our optimal demand that we're selling the number of is 24.25. So simply, the profit is going to be total revenue minus total costs. So that's one approach. Here, I did essentially the same thing, except for I just substituted in the price function times demand. So what you should get is the revenue is 318,000, the costs 274,000. The most profit you can make is 44,612.50 cents. Anybody else get that? Good. It's always nice when my calculations turn out. The break-even points, boy, there's lots of places where when you do the break-even function, a lot of places where you can make a calculation error. So what I suggest is that you sort of group it in intermediate steps. Don't do everything all at once in the calculator, but write down the substitutions and then maybe group things together a little bit. You know, here the 97 is this, and then I did the calculation inside the brackets and took the square root, and that's where the 59.74. So sort of break it up into steps, and it makes it easier to check your work if you have the intermediate calculations on the page. Besides that, it helps you get more partial credit if you do end up making a mistake. If you just show the equation and then the final answer, and your final answer is wrong, it's really hard for me to give you very much partial credit. But if you show me your intermediate steps, that makes it easier for me to give you partial credit if you made a mistake. Hopefully it's not an issue. Right. Good. All right. Now, as far as round-off goes, you'll notice that I rounded up for the first break-even point, and I rounded down for the second break-even point. Why do you suppose that's the case, that we should round up for D prime 1 and round down for D prime 2? A little bit of a loss, right. So sometimes the values between this is called the range of profitable demand. And the range of profitable demand does not begin until you have the first item number, the first number of demand that is actually leading to a profit. So that's why we should round up for the first one and round down for the other one. All right, now finally the drawing. I ran out of space on my page, so my drawing isn't the best. Let me zoom in to show you what I had in mind for that. All right. So we have our revenue curve, the total cost curve, and you'll notice I marked the points. Our optimal profit, you know, the maximum profit isn't the same thing as maximum revenue. And that's an important thing to remember, is that D star and D hat aren't the same thing. So you'll notice, for us, it's to the left of D hat is where I have my D star. So I've marked 24.25 as my optimum demand, and then the range of profitable demand is 392 until... Oh, did I write it down wrong? Yeah, 932, not 392. I had a moment of dyslexia as I was copying it on the paper there. As you could expect, Excel makes this sort of thing quite easy. So let me dim the lights a little bit and then show you on Excel how we could make this same curve. All right, so what I'm going to do for Excel is I'm going to have demand, I'm going to have price, revenue, cost, and profit. Demand is going to be, for this one, I'll have 100, 200, and we'll just find out for those certain level of demand, what price should I have in order to get that demand? So our price function was 180 minus 0.02 times the demand. So the price will be 180 times minus 0.02 times the demand. Okay, so this is showing what my price should be in order to get whatever the demand specified is. What should I do for revenue? What's the formula? The demand times price will give me the inflow of cash. That's my revenue. Okay, what about cost? Well, we had our cost function is $73,000 per month is the fixed cost, plus 83 times however many units I'm selling, demand. Okay, so now I have my cost column, and then profit is simply difference, right? Revenue minus cost. Okay, so it looks like I'm not yet at my first break-even point when I'm at 300. Even 500 doesn't take me to my next break-even point. 1,000, and it will. I'll be in a profitable area. So what did we say when we did the calculations? Our first break-even point was 932. If I go back to the one that isn't misprint. 932. So let's check that here. 931, not yet. 932, yes. All right, so now 1,000, 1,500. Let's do it by the 500s. And now we have our second break-even point between 3,500 and 4,000. What was the second break-even point? All right. Any questions so far? Let's do a graph. Which one? Well, it was 3918 point something. There was a decimal, right? I rounded down to make sure that it was profitable.
So is it a direct function?
A what?
A direct function.
Like, do everything I want kind of a thing?
You know, like a function, like rather than having data points, is there something where I can graph?
Let's graph it, yeah. Insert. We'll do, we'll smooth the curve since we know that's what it should be. All right, so our select data, we want to have on the x-axis should be our, oh, not the series name. So let's have this one be, here's our revenue curve. And we'll add a cost curve. And then we want to maybe have a profit curve. And we'll take a look at where we're at so far. It would be fun to see the revenue curve going down again. So let me change the range of values here to, let's see, let's do 2,000, 3,000, 4,000. All right. That's right. The gray curve is the distance between the revenue, the costs, and the revenue. Let's put in axis title. Oh no, the legend.
This is not very accurate, right? Because
No, it is very accurate.
you have data points and not exact, like it's an approximate.
Well, it's going to smooth the line, but even if we put in, you know, if instead of doing it by the thousands, if I did it by the one, the shape of the curve would be about the same. So this is the sort of thing we're going to do when we get back together in the lab next time. All right, now here we have a good curve. All right, so here, the orange line is costs, the blue line is revenue, and the gray line is the profit. Any questions? So right now you don't have a homework for this class. The things you should be thinking about is the quiz and the project. All right? Today's material is fair game for the quiz. That's right. On your way out, please put your in-class exercise on the table, and I'll see you in the lab on Thursday.